So this is our next lesson here in Unit 5-6. We're still working on proportional reasoning, and what we want to look at in this lesson is some material at a box B. We want to look at proportions. What are proportions, and how do we solve a proportion? So first off, what is a proportion? A proportion is a statement that two ratios are equivalent. So we looked at equivalent ratios in the first lesson. Okay, so if we have a ratio like 2 to 3, and we say that this ratio is equivalent to the ratio 4 to 6, this whole thing here, both ratios and that equal sign, are what we call a proportion. Okay? We could also do this in terms of fractions. If we have a ratio 1 to 5 that we would write as the fraction 1 over 5, we can say that this is equal to 3 over 15. And again, this whole thing here is a proportion. So both of these are proportions here, just different ways of writing it. So first thing we want to be able to do is determine if two ratios that we have are proportional, or if we can put that equal sign in between them and they form a proportion. So can we multiply or divide both terms in the first ratio by the same number to get the second ratio? And this is just the method that we used to find equivalent ratios in the first lesson. So if we can take, if we look at this possible proportion here, 5 to 20 equals 50 to 200, we can see that if we take our 5 and multiply by 10, we're going to get 50. So we take the first term in the first ratio, multiply it by 10, and we do get the first term in the second ratio. If we can also take the second term in the first ratio, multiply it by 10, and get the second term in the second ratio, then yes, this is a proportion. If we look at the second example over here on the right, in this case, to get the first term in the second ratio from the first term in the first ratio, we would have to divide by 3. And sure enough, if we divide by 3, if we take the second term, divide by 3, we get the second term over here. So again, this is a valid proportion. The other way of thinking about this is, can we multiply or divide the first term in each ratio by the same number to get the second term in the same ratio? So if we look at this example, we've got a 7 as our first term and a 21 as our second term in the first ratio. We can see that if we take our 7 and multiply by 3, we get our 21. So the second term is 3 times the first term. Is the same thing true in our second ratio? Well, yes, it is. If we take our 3 and multiply by 3, we get 9. So this is a valid proportion. Let's see if the same thing holds true in our second example over here. We've got 18 to 9 in our first ratio. Well, that 9, to get the 9 from the 18, we have to divide by 2. Does the same thing work in the second term of this proportion? Well, yeah, if I take my 14 and I divide it by 2, I get my 7. So that's a valid proportion. The other way of thinking about this is, we talked in the first lesson about putting ratios in simplest form. So you could take both of your ratios in your proportion and reduce them down to simplest form and see if they are the same. So in our example here, our possible proportion is 10 to 1 equals 120 to 12. Let's put each of these ratios into simplest form. Well, 10 to 1 is already in simplest form, so we don't have to do any work here. We'll just write out that this is already in simplest form. Well, what about 120 to 12? Well, let's see. If we put this in simplest form, we would have to divide each of these by 12. So 120 divided by 12 gives us 10. 12 divided by 12 gives us 1. And lo and behold, our two ratios here in simplest form are the same. So this is a valid proportion. Let's take a look at the second one over here. We got 75 to 25 equals 100 to 300. Let's put both of these in simplest form. So for the first ratio, I can divide both of these by 25 to get this in simplest form. So if I do 75 divided by 25, I get 3. If I do 25 divided by 25, I get 1. So in simplest form, this ratio is 3 to 1. For my second ratio, I'm going to have, let's see, I've got 100 to 300. I can divide each of these by 100. That's going to give me the ratio, let's see, 100 divided by 100 is 1. 300 divided by 100 is 3. So these are my two ratios in simplest form. Are they the same ratio? Well, no, they are not. In our first ratio, we have the 3 to 1. In the second ratio, we have 1 to 3. Okay, so those are different ratios because, again, the 3 and the 1 are in different places there. So those would not be equivalent ratios. Now, probably the most important thing that you want to take away from this lesson is what we're going to take a look at next. We're going to take a look at solving proportions. Okay? So often what you're given is a question like this one here. Find the value of x if 2 to 5 is equal 8 to something. Okay? And we want to know what that something is. What value of x can we put in there that is going to make this proportion true? The easiest way to do this is to first, well, I've written this out in steps here. Step 1, write each ratio as a fraction. Put the first term in each ratio in the numerator. So let's write this out as fractions. 2 to 5 becomes 2 over 5. This is going to be equal to 8 to x becomes 8 over x. Step 2, we want to cross multiply. So what that means is we want to take what is in the denominator over here, and we want to multiply it by what's in the numerator on the other side. So we'll cross like this, and we'll do the same thing across like this. So what that'll give us is, doing x times 2 gives us 2x. We put the equal sign in the middle. Doing 5 times 8 gives us 40. So there's our cross multiplication step. Now, we just want to solve this thing for x. Well, if we have 2x equals 40, we remember from the previous unit on solving equations that if we want to isolate x or get x all by itself, what we have to do is divide both sides by the number in front of the variable. So we've got that 2 out front. We're going to divide by 2 over here and 2 over here. And that's going to leave us with x equals 20. And that's our solution. If we were to sub 20 into this original proportion up here, that would make that proportion true. So on the back of the page, I've got a number of examples that we can practice on. So let's do the first one here together, and then you might want to pause the video and try the next few on your own, and then start it again and check the solutions. But let's just look at the first one here. So step 1, we take our ratios. So we have the proportion 2 to x equals 6 to 9. Step 1, take our ratios and write them as fractions. So this will become 2 over x equals 6 over 9. And I make sure that I put the first term in the numerator every time. Then I'm going to cross multiply. 9 times 2 is 18. X times 6 is 6x. And then I see that 6x, so I'm going to divide by 6 and divide by 6. And I get 3 equals x. So x equals 3 is my solution. All right. So pause the video now, try questions 2, 3, and 4, and then start it again and check your solutions. Okay, for question number 2 here, we'll write these as fractions. 4 over 15 equals 8 over n. We're going to cross multiply to get 4n equals 15 times 8 is 120. Divide both sides by 4. Gives us n equals 30. Okay, it's a good idea to keep a calculator beside you while you're doing these ones, and you can do most of this math just in your calculator. All right, number 3 here. Z to 14 equals 10 to 20. Again, write these as fractions. Z over 14 equals 10 over 20. Cross multiply. Z times 20 gives us 20Z. 14 times 10, 140. Then we'll divide both sides by 20. And we get Z equals 7. Is our final answer. The last one here, we have 3 to 21 equals x to 56. Write both of them as fractions. 3 over 21, x over 56. Cross multiply. 21 times x is 21x. 3 times 56, punch that into our calculator, 168. We want to divide by 21, divide by 21. On the right-hand side, we have x. On the left-hand side, we have 8. So our answer is x equals 8. And that's solving proportions.